Okay, so we're going to finish off this section today, section 8.3, and then like I said, we'll spend a couple days on 8.4 next week, and probably have our 7-8 exam on Thursday by the looks of things. Okay, so I will be giving you your review assignment for chapters 7 and 8, and that will be due like all the other ones have been to help you get ready for that test. So we're talking about, again, using logarithmic equations to solve problems. The human ear is sensitive to a large range of sound intensities. Scientists have found that the sensation of loudness can be described using a logarithmic scale. The intensity level, beta, that's just the Greek letter beta, in decibels of a sound is defined as beta equals 10 log I over I sub 0, where I is the intensity of the sound in watts per square meter, and that is in watts per meter squared. I sub 0 is 10 to the negative 12 watts per meter squared, which corresponds to the faintest sound that can be heard by a person of normal hearing. Audiologists recommend that people should wear hearing protection if the sound level exceeds 85 decibels. The sound level of a chainsaw is about 85 decibels. The maximum volume setting of a portable media player with the headphones is about 110 decibels. How many times as intense as the sound of the chainsaw is the maximum volume setting of the portable media player? So if we want to know how many times more intense the media player is compared to the chainsaw, that will be found by division. If you want to know how many times greater one thing is compared to the other, you will divide those two, whatever's being measured. All right? And to set this up, remember that the quotient law of logarithms involves subtraction of individual logs. If you have subtraction of individual logs with the same base, you can combine them into one expression using the quotient law. So because of that, we're going to set this up initially by using a subtraction statement involving logs with the same base, which will then allow us to use the quotient law, combine them into one using a quotient. We start with this general equation for the decibel level, which is beta equals 10 log I over I sub 0. Right, we're giving that. And we have beta 1, which will be 10 log I sub 1 over I sub 0. And then we have beta 2, which will be 10 log I sub 2 over I sub 0. And I'm going to say that beta 2 corresponds to the media player, where beta 1 corresponds to the chainsaw. And again, we need to write a subtraction statement here involving the individual logs so that we can combine them into one expression using the quotient law. And we'll do that by going beta 2 minus beta 1. So beta 2 is 10 log I sub 2 over I sub 0 minus beta 1, which is 10 log I sub 1 over I sub 0. Now we know what beta 2 and beta 1 is. The decibel level of the media player headphones is 110 decibels. Minus beta 1 is the decibel level of the chainsaw, which is 85 decibels. So we can plug those values in. And on the right side, What I'm going to do next is take out a common factor of 10, which will give us log of I sub 2 over I sub 0 minus log of I sub 1 over I sub 0. So on the left side, 110 minus 85 is 25, and that will equal 10. And inside the brackets now, we have the difference between two logs with the same base. We can use the quotient law to simplify that, to write it as a single log. And we do that by taking the quotient of the two arguments. And we combine 2 into 1 by using the quotient law. Continuing on, I can divide the 10 on both sides. That'll give me 2.5 on the left. And on the right side, I'll have log of, inside the brackets, we're dividing two fractions, two rational expressions. We divide fractions by multiplying by the reciprocal. And this is why we didn't put in our I sub 0 value that we were given. We're told what I sub 0 is. It's that faintest sound that can be heard by a person with normal hearing. We didn't put that in because they now cancel out. We have an I sub 0 on the top and bottom. They cancel out. So that leaves us with 25 or 2.5, I should say, equaling log of I sub 2 over I sub 1. And that's what we're trying to find the value of. What is I sub 2 divided by I sub 1? That'll tell us how many times more intense the sound of the media player is compared to the sound of the chainsaw. I sub 2 over I sub 1 is what we're trying to find. And we can determine that by remembering this is a common log, no base indicated, means base 10, and we can change from logarithmic to exponential by starting with the base and cycling through. You'll get 10 to the power 2.5 equals I sub 2 over I sub 1. We now have that expression by itself, isolated. And so our answer will be whatever 10 to the power 2.5 is. It's approximately 316 times more intense. So again, the key is remembering or realizing that to determine how many times more intense one thing is compared to the other, we need to get a division statement. And we get a division statement by starting with the difference between two individual logs with the same base. We combine them together using the quotient law, and now we have our division statement that we then solve for algebraically. Okay? So this next question is basically part B. It has the same body, the same introduction. So everything is the same. Only now it says sounds are at most 100,000 times as intense as a whisper are considered safe. The sound level of a whisper is about 20 decibels. What sound level in decibels is considered safe no matter how long it lasts? So to do this, we're going to use a formula that we developed on the previous page, and that was that B sub 2 minus B sub 1 equals 10 times the log of I sub 2 over I sub 1. This is a formula that we basically developed on the previous page. So in this case here, we want to find out what B sub 2 is. B sub 1 will be the one with the smaller intensity, which is the sound level of a whisper. Sounds that are at most 100,000 times as intense as the whisper are considered safe. So we want to know what B sub 2 is, and B sub 2 will be the decibel level of a sound that is 100,000 times more intense than the sound of a whisper, which is 20 decibels. So we need to solve for B sub 2 if B sub 1 is 20. Now, on the right side we have 10, but this part here, sorry, not the log part, the I sub 2 over I sub 1, like we saw on the previous page that we did, that represents how many times more intense one sound was compared to the other. In this case, we're told what that number is, the fact that we're looking for a sound that is 100,000 times more intense than the sound of the whisper. So in this case, we're given I sub 2 over I sub 1. It is 100,000. So in this case, we can calculate what the right side is. Right? That is a common log on the right. So it's just 10 times the log of 100,000. I think the log of 100,000 is 5 times 10 will give us 50. So B sub 2 minus 20 will equal 50. And then if you add the 20 to both sides, you'll get 70 decibels. So that's a sound level that is 100,000 times more intense than the sound level of a whisper that you can listen to for as long as you want, and it should not affect your hearing. Okay? So on the next page, the pH scale is used to measure the acidity or alkalinity of a solution. The pH of a solution is defined, again, by a logarithmic equation. pH is negative log H positive, where H positive is the hydrogen ion concentration in moles per liter. A neutral solution, such as pure water, has a pH of 7. Solutions with a pH of less than 7 are more acidic, where solutions with a pH greater than 7 are more alkaline. The closer the pH is to 0, the more acidic the solution is. A common ingredient in cola drinks is phosphoric acid, the same ingredient found in many rust removers. Isn't that nice? A cola drink has a pH of 2.5, where milk has a pH of 6.6. So it is more acidic than water. Milk is. Because our water is neutral, and that is a pH of 7. How many times as acidic as milk is the cola drink? So again, we're going to set up the same type of equation that we did in part A on the previous question where we were dealing with sound level intensities. We'll start with the fact that our pH level is found by going negative log H positive. And we're going to have two different pH levels. We'll have pH 2, which will be the one that is more acidic. That will be negative log of H positive 2. And we'll have pH 1, which will be the one that is less acidic, is negative log H positive 1. And so again, the pH 2 will be the one that is more acidic. This will be the cola. And the pH 1 will be the one that is less acidic. That'll be for the milk. The cola is more acidic than the milk. We want to know how many times more acidic it is. That's what we're trying to do. So like we did before, we'll set up a subtraction statement, because that will allow us to use the laws of logarithms, use the quotient law to get a division. How many times more acidic is cola compared to milk? We have to divide them to get that. And the quotient law tells us that we first have to start with a subtraction statement. So it'll be pH2 minus pH1, which will equal negative log H positive 2 minus negative log H positive 1. We have the two pHs. The pH of the cola is 2.5. The pH of the milk is 6.6. On the right side, the minus minus would become a plus positive. So if we want, we could rearrange the terms. The log of H positive 1 would be first as a positive minus the log of H positive 2. But the problem with this would be that would put the H positive 1 on top. We want it on the bottom because the cola is more acidic than the milk. Okay, so that's fine. We just won't do what we just did. And I explain why. So if we start with changing the minus minus to a plus positive, but remember, we need to get the negative sign in between the two, and we want the H positive 2 to be first. So all I'll do on the right side is take a common factor of negative 1 out. And that'll give me the minus in between the terms. Okay? But on the left, I'm going to get a negative value as well, because 2.5 take away 6.6 is negative 4.1. Again, I'll take out a common factor of negative 1 on the right, which will give us log of H positive 2 minus the log of H positive 1. I will divide both sides by negative 1, which will give me positive 4.1 on the left. And I'm left with what's inside the brackets, which again is a subtraction statement. I can combine those into one expression, one logarithm expression, using the quotient law. That'll be the log of H positive 2 over H positive 1. And we want to find out what that is. What is H positive 2 over H positive 1? What does that equal? That'll tell us how many times more acidic the cola is compared to the milk. And we can do that by, again, remembering that's a common log base 10. We can start with the base and cycle through. You'll get 10 to the power 4.1 equals H positive 2 over H positive 1. And so our answer will be whatever 10 to the power 4.1 gives us. That'll be how many times more acidic the cola is compared to the milk. 10 to the power 4.1. Approximately 12,589 times more acidic. So H positive 2 over H positive 1 is approximately 12,589 times more acidic. Okay? Now part B says the apple is 5 times as acidic as a pear. If the pear has a pH of 3.8, then what is the pH of the apple? So that's on the next page for you. And once again, we've developed this equation from the previous page. And that equation, just like the one we had with the sound levels, is pH2 minus pH1 equals 10 times the log of hydrogen positive 2 over hydrogen positive 1. Actually, there wasn't a 10 in front. There was a negative sign in front. So that's basically the formula that we developed on the previous page. So an apple is 5 times more acidic than the pear. So the apple would be pH 2. The pear would be pH 1. Because the more acidic one comes first. And so once again, H positive 2 over H positive 1, that'll be 5. We're told that the apple was 5 times more acidic than the pear. And that's what H positive 2 over H positive 1 represents. How many times more acidic is the one compared to the other? That's what we solved for in the previous question. We got our answer of 12,589 times more acidic the cola was compared to the milk. So that'll be negative log 5. On the right side, the pH of the pear, which is pH 1, is 3.8. So we need to solve. We need to solve for pH 2. So in this case here, we can divide both sides by negative 1. And actually, we don't have to do that because we can actually evaluate what the expression on the right side will give us. That is a common log. So we can go negative log of 5. And that'll be negative 0.699 approximately. But we'll keep that in our calculator. And so then to get pH 2 by itself, we will just add 3.8 to both sides. We'll take that negative decimal that we found, we'll add 3.8, and we'll get approximately 3.1. So there's our answer. That is the pH level of an apple that is 5 times more acidic than a pear. It goes from a pH of 3.8 to a pH of 3.1. Okay? All right, and that's it for 8.3. So some questions that you can work on for practice. Will be those questions. And I'm collecting this for marks. Okay, so this one will be due. And like I said, we've got 2 more days now in this chapter to do 8.4. After that, we will have our test on chapters 7 and 8. Okay?